This course specialist production training. We will discuss pyroprocessing in cement industry. Course 1. This subject will contains Course 1. Objectives, pyroprocesses, material and gas flow, kill reactions and zones, fuel characteristics, process equipment. Course 2. Auxiliary equipment, coal mill control, clinker cooler control, kill control. Objectives: understand kill operational fundamentals, develop knowledge of process and auxiliary equipment, learn the control variables and levers required to operate coal, coke mill, reciprocating grate clinker cooler, rotary cement kiln. Pyroprocesses. Pyroprocessing is the act of converting pulverized, raw materials containing prescribed oxides, into an intermediate product known as Portland cement clinker, through the controlled application of intense, sustained heat. Main types of pyroprocesses. 1. Long wet. 2. Long dry. 3. Preheater. 4. Precalciner. 1. Long wet process. One of the most important characteristics of this method. The nature of slurry. Slurry, 30 to 40% water. The length for rotary kiln. 150 to 230 meter. Consistent quality. Poor fineness control. Chains provide heat transfer. Poor fuel consumption. 1,400 to 1,650 kilocalorie per kilogram. Inexpensive fuel. 2 to 3.5 hours, residence time. 2. Long dry process. One of the most important characteristics of this method. Powdered kiln feed. The length for rotary kiln, short than wet process. 90 to 150 meter. Variable feed quality. Improved fuel consumption. 1,100 to 1,250 kilocalorie per kilogram. Fineness control. Increased dust loss. 1.5 to 2 hours, residence time. Long dry process. In this slide, we show the generalized diagram of a long dry process kiln. Three. Preheater process. Powdered kiln feed. The length preheater is approximate 70 to 90 meter. Particles suspended in gas. Increased surface area, exposed to heat. Improved heat transfer. 50 to 65% calcination. Improved fuel consumption. 830 to 950 kilocalorie per kilogram. Half to 3/4 hour, residence time. More sensitive to changes. Calcination. CaCO3 plus, heat equal, CaO plus, CO2. MgCO3 plus, heat equal, MgO plus, CO2. 4. Precalciner process. Powdered kiln feed. The length preheater is approximate 55 to 75 meter. 90 to 95% calcination. Shorter kiln. Reduced kiln heat load. Increased refractory life. Improved fuel consumption. 720 to 830 kilocalorie per kilogram. A third to half hour, residence time. More sensitive to changes. 2. Firing points. Calcination. CaCO3 plus, heat, equals CaO plus, CO2. MgCO3 plus, heat, equal MgO plus, CO2. Material and gas flow. In this figure, the path of gases and raw materials during the clinker manufacturing stages is shown. 1. Gas. Watch the path of pure gases entering, or leaving the clinker process in this fire. Through several points. Bypass intake point, at the entrance to the rotary kiln. The clinker cooling fans, in the cooler. Air suction through, fans filters. The burner of the rotary kiln. 2. Dust-laden gas. Watch the path of dust-laden gas, entering or leaving the clinker. Through several points. Air exits through the preheater, by suction the ID fan. Dust-laden gas air suction via bypass. Dust-laden gas exhausts, through the cooler filter fan. 3. Material. Watch the path of material, entering or leaving the clinker. The descent of the material begins, from the top of the preheater through the cyclones, and during this descent, the material mixes with the hot gases, that come out of the rotary kiln. Cyclone operation. In this figure, we will explain the idea of the operation of the cyclone. A cyclone is a centrifugal separator in which particles, due to their mass, are pushed to the outer edges as a result of centrifugal force. The particles which are present in the air are forced to the outer edges, and fall to the bottom of the separator. The important points in cyclone. 1. Clean gas, suction via ID fan. 2. Negative pressure. 3. Top cylindrical section. 4. Bottom conical section. 5. Airlock. 6. Outlet thimble. 7. Dust-laden gas. 8. Inner vortex. 9. Outer vortex. 10. Materia. Kiln reactions. Briefly, we review the reactions that occur inside the rotary kiln. Classroom chemistry. C equals carbon. S equals sulfur. etc. Cement industry shorthand. C equals CaO, lime. S equals SiO2, silica. etc. C3S equals 3CaO, SiO2 equals tricalcium silicate. C2S equals 2CaO, SiO2 equals dicalcium silicate. C3A equals 3CaO, Al2O3 equals tricalcium aluminate. C4AF equals 4CaO, Al2O3A Fe2O3 equals tetracalcium aluminoferrite. Kiln reactions. In this slide, the types of reactions, and where they occur inside the rotary kiln, are shown. 1. Free water. 2. Clay decomposition. 3. Limestone decomposition. 4. Formation of initial compounds. 5. Initial formation of C2S. 6. Formation of melt. 7. Formation of C3S. We also explain the internal division of the rotary kiln. 1. Dehydration zone, the gases temperature, 425 degrees C. Materials temperature, 65 degrees C. 2. Preheating zone, the gases temperature, 500 degrees C. Materials temperature, 100 degrees C. 3. Calcination zone, the gas's temperature, 808 degrees C. Materials temperature, 558 degrees C. 4. Clinkering zone, the gas's temperature, 1208 degrees C. Materials temperature, 1108 degrees C. 5. Cooling zone, the gas's temperature, 1758 degrees C. Materials temperature, 1458 degrees C. 6. At the entrance cooler, the gas's temperature dropped to 1758 degrees C. Materials temperature dropped to 1458 degrees C. Kill reactions. In this slide, we show the typical reaction process in a cement kilns at cement industry. Kill reactions. In this slide, we show the excess CaO results in impossible to burn feed. Kill zones. Dehydration zone in the wet process. The temperature range, in this region, 50 to 100 degrees Celsius. Temperature range, at drive-off free moisture, 100 degrees Celsius. In a dry process, this occurs within the first few seconds. Preheating zone. The temperature range, in this region, 100 to 550 degrees. Temperature range, to drive off bound moisture. Chemically bound water, in clay minerals, 550 degrees. Prepare for calcination. In a preheater this occurs, in the top two stages. Calcination zone. Drive off carbon dioxide, CO2. CaCO3, equals CaO, plus CO2. MgCO3, equal MgO, plus CO2. Endothermic reaction. Heat and gas is absorbed by material. 550 to 800 degrees. Formation of Ca, C2F, and C2S begins. 800 to 900 degrees. Formation of C12, A7 begins. 900 to 1100 degrees. Formation of C3A, C4AF begins. All CaCO3 is decomposed, and free limestone reaches maximum. Clinkering zone. Upper transition, sintering, and lower transition zones. Final stages of clinker, compound formation. Clinker bed, is at its most viscous. 1100 to 1200 degrees. Formation of majority, of C3A and C4AF. 1260 degrees. Liquid formation begins. 1200 to 1450 degrees. C2S, combines with free lime to form C3S. Exothermic reaction, gives off heat. Disappearance of free lime. Cooling zone. 1450 to 1370 degrees. Solidification, of partly liquid compounds. Cooling rate affects quality and grindability. A light crystal growth. Freezing, of MgO. Fuel characteristics. Fuel types. 1. Fossil, it contains coal, fuel oil, natural gas. 2. Alternative fuel, it contains petroleum coke, tire-derived fuel, liquid waste fuel, etc. Fuel properties. Chemical composition. Hardness. Fuel forms. 1. Solid. Requires grinding to achieve adequate surface area. Must remove moisture. Need to account for ash in clinker. 2. Liquid. Must heat to reduce viscosity. Requires atomization. High pressure nozzle. Dual fluid nozzle. 3. Gaseous. Low emissivity, poor heat transfer. Emissivity, the ability of a surface to emit radiant energy, compared to a black body. Alternative fuels. Petroleum coke. Hard to grind, but high heat content. High sulfur. Tires. Low specific surface area. High residence time. Localized combustion. Liquid waste fuels. Stringent permitting. Additional sampling, and testing. Chlorine, heavy metals. Community acceptance. Fuel properties. Chemical composition, it includes 1. Combustion. Carbon, C plus, O2, equals CO2, plus heat. Hydrogen, H2, plus half, O2, equal H2O, plus heat. Sulfur, S plus, O2, equal SO2, plus heat. Hydrocarbon, CmHn, plus, M plus N over 4, O2, equal MCO2, plus, N over 2, H2O, plus heat. 2. Sulfur. 3. Chlorine. 4. Volatile matter. Lower Vm requires finer grinding. Hardness, it includes Hardgrove, grindability index. Harder to grind equal, lower HGI. Easier to grind equal, higher HGI. Process equipment, at wet system. 1. Suspension preheater. 2. Precalciner. 3. Chain system. 4. Rotary kiln. 5. Clinker cooler. 6. Firing system. Rotary kiln, consisting of 1. Steel shell. 25 to 75 mm, thickness. 2. Supports. 3. Tires. Not fixed to shell. Allow for differential expansion. 4. Seals, the function. Prevent air in leakage. 5. Refractory lined, the function. Protect shell. Different applications. 1. Abrasion. 2. Thermal resistance. 3. Bonding. 6. Main drive. Desired shell temperatures, below 425 degrees. Chain system, the function. 1. Used for heat transfer. Kilns would have to be 2.5 times longer, without chains for the same heat exchange. 2. Conveys material. Screws, material through kiln. 3. Dust collection. Captures dust and places, back into load. In this figure explains, typical chain arrangement. Dust curtain, knocks dust from gas stream. Plastic zone, feed becomes tacky. Bare zone, allows gas temperatures and material flow to equalize, permits installation of thermocouples. Radiation curtain, stainless steel, absorbs the most heat. Suspension preheater. 1. Dust in suspension. Efficient heat transfer. 2. Multiple stages. More stages, better thermal efficiency. Drying gases. 4. Raw mill or cement mill. 3. Counter-current and concurrent flow. 4. Meal valves. Freely moving. Prevent backdraft. 5. Nuclear plug detection. This figure shows the path of the material and gases inside the preheater. It also shows the components of the preheater. To kill ID fan, cyclone, duct, meal valve, riser. Stage 1. Stage 4. Precalciner. Most important characteristics for precalciner. 1. Secondary firing. Improved NOx control. 2. Air through or air separate systems. 3. Improved calcination. Less gas through kill. 4. Reduced thermal loading. Improved refractory life. 5. Fewer mechanical components. Shorter kill. Fewer tires. Less steel. Less refractory. Smaller motor. Clinker cooler. One of its most important characteristics. 1. Reciprocating grate. 2. Cool and convey clinker. 3. Recuperate heat. Secondary and tertiary air. 4. Air distribution. Multiple control points. 5. Take-off points. Tertiary air, raw mill, and cement mill. 6. Quality control. Quench air. Reduced alight, C3S size. Improved grindability. 7. Clinker less than 25 mm. Impacts grinding capacity. Firing system. 1. Coal mill, ball, or bowl. 2. Direct or indirect, fired. 3. Burner. Single channel. Multiple channels. 4. Fuels. Fossil. Alternative. Hygroscopic moisture. Coal mill. Purpose. 1. Pulverize solid fuels. Increase surface area. Increase rate of reaction. 2. Dry fuel. 3. Increase air temperature. Primary air, direct fired system. Coal mill components. 1. Raw fuel from way feeder. 2. Airlock. 3. Rotating table. 4. Worm gear. 5. To fan. 6. Classifier. 7. Rolls. 8. Drying gases. 9. Tramp chute. Burner pipe. Consisting of 1. Air nozzle. 2. Stationary burner part. 3. Support beam. 4. Spindle gear unit. 5. Suspension for movable burner part. 6. Movable burner part. Burner pipe. Consisting of 1. Refractory. 2. Axial air. 3. Coal and conveying air. 4. Swirl air. 5. Oil sprayer. Direct firing system. The direct firing system, consisting of raw coal, coal mill, System fan. Burner. Hot gas generators, air heater. Bleed-in air damper. Dust trap cyclone. Tempering air. From clinker cooler. Note: because of the potential explosion hazard, when mixing fuel with oxygen, some systems use preheater gases, with lower, 2%, oxygen to reduce the risk. Semi-direct firing system. The semi-direct firing system, consisting of raw coal, coal mill, cyclone, rotary feeder, system fan, primary air fan, venturi, burner, from clinker cooler, tempering air, dust trap cyclone, bleed-in air damper, hot gas generators, air heater. Indirect firing system. The indirect firing system, consisting of raw coal, coal mill, dust collector, system fan, primary air fan, cyclone, rotary feeder, storage bin, venturi, burner, from clinker cooler, tempering air, dust trap cyclone, bleed-in air damper, hot gas generators, air heater. Thank you for showing interest. With family greetings, everything about the cement industry. I hope for your support by subscribing to the YouTube channel.